Hi, this is Roma from Lucintel, bringing you your latest market insights and trends. And today we're talking about private 5G networks, sort of. So, private 5G networks have been all the buzz lately within the IoT industry, within the network industry. People have been talking about this for quite a while, whether it be a private 5G network or a private network in general. And companies are quite eager to implement this because you have higher speed, more privacy, it's far more secure, and a lot of reasons why companies would want this. But today we're here to talk about why private 5G networks are awesome, but that's just the first step. That's not the only thing you should do, is just implement it. There's a next further critical step that is also important. And we're going to specifically be talking to Bobby Perkins from DGS, which is a spectrum management company, and we'll be discussing the importance of adding spectrum management as well if you're going to implement a 5G network in order to create efficiency and security. Let's go check out the conversation.
Yeah, right. And can you explain why this is so important for like private networks that are really getting a buzz right now and starting to become quite a thing? Why is it so important for someone who is implementing a private network to also make sure to do this as well, not just implement the private network?
Great question. So private networks, private 5G or private LTE in the CBRS bands, it's taking off, right? And it allows the end user to have carrier grade services and carrier grade applications, and mission critical applications at the ready,
Yeah.
utilizing high bandwidth. Now the challenge with that is we do have SaaS providers, great, but the SaaS providers are limited, and they only provide they only provide a limited capability when it comes to channel allocation, redundancy, resiliency, and efficiency at the network edge. So our capability provides that resiliency, it provides that security, that level of interference detection, and then also provides that optimization where you can gather those data analytics and do through our AI platform and make decisions in a faster and more efficient way. So having that situational awareness, having that command and control at the edge, it provides for a better network in the private 5G space.
Yeah. And can you kind of talk about how the implementation of you guys' service works? I know you had touched on it a bit before, but what was it that you said you embed into the system?
Sure. So there's inside here. There's also different antennas, right? And each the antennas also provide the receiving antennas, and they can provide different types of gathering points within within the ecosystem. Inside the hardware itself, AI enabled once again, but the software can also be deployed within any hardware. So we're vendor agnostic when it comes to hardware. It can be on any hardware platform. And the positive thing about that, even though it's in this specific chassis, we can also change it to a different chassis as well. So inside it's really running all of this, the antennas, the filters, but also the software that's going to maximize your 5G infrastructure.
Yeah. Okay. And what would you say right now are kind of some of the biggest cybersecurity threats we're seeing, or things with like leakages? What are kind of ways to, first of all, the biggest issues with that, and also ways to deter from that?
I say one of the biggest challenges within RF is overpropagation of RF. We say, well, we have this coverage area, but we want more customers to be engaged in this activity. We need to have more customers on the network or end user devices, so we'll amp up the power. That's not always the solution. Sometimes you may have to bring the power down and provide more access points. But the challenge, even with that scenario, you still want to be able to interrogate your network from an RF perspective and make sure that spectrum is being maximized and utilized efficiently within those channel allocations. You do not want to just overpower a network and create more noise on the network. And that what that'll do too is it can also bring your entire network down as well. So from that perspective, making sure that you have the right channel allocation, and you're also the right devices, whitelisting your network, providing a cybersecurity zero trust architecture is also part of it. But also when it comes to network spectrum service enabled awareness, is being able to optimize the network from a channel and protocol standpoint. So each spectrum has its own set of protocols. So when you can whitelist your spectrum, you can also whitelist your protocols, which then you can whitelist your SIMs or your eSIMs, and then your devices. So now you've basically created a very more secure network within not only within your spectrum, but also within your 5G space.
Okay, and I think these are pretty important topics for people to know about because a lot of times you just kind of implement the first step, you're not sure all these other things that are necessary. So I think this is great that you were able to discuss this. And you mentioned the whitelisting. Can you explain that a little bit more?
Yeah, traditional whitelisting is between MAC addresses and SIM cards and IMEIs. But again, when you look at, you peel back the onion, every frequency and channel has its own set of protocols and security posture. So within the 5G space and private 5G space, there's new ciphers. So what you can wind up doing is provide a level of not only cipher security, but also protocol security on the actual frequency to not only pull that data from out of the air to identify who that interferer could be, but also as you're looking at the network from, is that device working properly? Is that device really active? Instead of just sitting on the network, is it actually pulling data and being an active attendant, if you will, on the network? We have that capability. The one other part that I was going to mention too, how to combat, some of the challenges as far as not just the interferers or interrogators that are out there on the network, but also probably the biggest challenge is oversaturation and congestion. So when we know we can see through this network, through our platform, the level of congestion from frequencies, capacity management, data usage, we can identify those characteristics and a lot more to be able to tell that provider or that specific customer, this is how we would want to help you and maximize your infrastructure so that it can not only be resilient, but that end user can be able to access those mission critical applications.
Yeah.
And the last other part around private 5G networks too is the utility industry. So when you look at the utility industry, I'm a Floridian, so there's quite a lot going on right now. But part of that utility industry also should encompass smart grids. So being able to understand when that solar panel should tilt, they're automated, right? But also when does that panel, when does it stop working? What's the end of life? How can we maintain that panel so that way we can always have more energy feeding back onto the grid, not just for the utility structure as a whole, but now that we're seeing a lot more utility companies adding on solar farms to generate more power onto the electricity onto the grid, we have to be able to manage those solar farms as well.
Yeah. And do you also see, so we talked about different customers that would be using things like private networks. Do you see this possibly transcending into manufacturing as well, as smart manufacturing is becoming more of a topic and these factories are becoming fully automated?
Yes. Not just factories, but we'll call them smart factories. From a Department of Defense standpoint, the Defense Logistics DLA agency, as we call it, they have a lot of, not manufacturing, but warehouses as well. So warehouses and factories kind of go hand in hand. They're big environments, lots of infrastructure that's there. But the one liner there too is being able to understand where those assets are within a warehouse, prioritizing when those shipments of those assets materials need to go to a flight line or need to go to an aircraft carrier or maybe just need to go onto a FedEx or a UPS, right? From a factory standpoint, it's the robotics. It's managing, again, that edge device. In this case, it could be a robot of some sort or many robots that are putting together vehicles. It could be putting together chairs, antennas, whatever the case may, whatever the end state is of that, whatever. These factories need that level of carrier level of carrier networks around private 5G, but also they still need spectrum management so that we can do what? Manage the spectrum, optimize the usage, the channel allocation, and then be able to provide that level of service that we're all talking about as it relates to private 5G networks, which is high bandwidth and low latency.
Yeah, okay. And this final question that I know you did touch on a bit, but just one more time to repeat. What are the main kind of threats one would encounter if they didn't, implement something like the spectrum management? And what are the biggest causes for these threats, kind of? So just
the side effect of these threats is that we have no network. We may have five bars. We may have an IoT device that says it's connected to a network, but it's not able to respond on the network. Which in that case, we're losing dollars and cents. The factory could be down. The machines aren't being made. The precise farming that we want to go ahead and harvest. Well, we can't harvest because our plants are not up to par. So, these networks have to be not only sustainable and resilient, but with a platform like ours, where we have spectrum management in place, we are, I don't want to say future proofing, but what we are doing is providing a level of not only security, but a level of management to enhance the usability of the network for what it's made for.
And the security you mentioned, like what are the main kind of threats to the security that you guys are seeing mainly? That
Yeah, so there's unfortunately there's people that do nefarious things like jamming the network. If they know, for example, what spectrum and channel that you're operating on in that given environment for a private or even public network, they can go out there and jam the network. Well, if you have a group of people that are doing something like that, well, that's a planned effort. If we already know that we have our sensors deployed in that given area, and over time we see that this is the RF signature of that environment, great. The moment that an interferer comes into that environment, we'll know it very quickly, because the data has shown that this is our current state. This is what we're used to seeing as a current state from a spectrum management standpoint. And the moment that interferer with their jammers comes in, we know that we need to alerts go off, right? So these are I don't want to say predictive, but these are the real time things that we can do to help maximize not only our network, but also minimize the negativity and not just the interference, but the those that are trying to do nefarious actors out there on the network.
Yeah, amazing. Okay, thank you so much.
All right.
Thank you so much for watching. Check out the link below to read the full article on this topic and to see others like it, and to also gain access to our website where you can see our further capabilities in consulting and market research.